Today's lesson is about the Pythagorean theorem. Now, the Pythagorean theorem is one of the greatest achievements in mathematical history. Quite a bit of our world is actually based on this, more than I think you even realize at this moment. It is very, very important, and so it's very important that we understand it. The Pythagorean theorem is a property of right triangles. To that you might say, what is exactly a right triangle? A right triangle, by definition, has one 90-degree angle. One 90-degree angle means that two of the sides of the triangle are perpendicular. You'll notice in this right triangle I've drawn over here, we have our right angle right there, meaning this side here and this side there are both perpendicular lines. One other very important feature of a right triangle is called the hypotenuse. A hypotenuse, by definition, is the longest side of a right triangle. The hypotenuse is the longest side of a right triangle. It's usually fairly obvious what side that is. If you're struggling, know that the hypotenuse is always going to be opposite the right angle. So it's always going to be the side that doesn't touch the right angle. So in this case, the hypotenuse is this line right here, okay? Now, from here, we have to name the sides of our triangle. The man that discovered this, Pythagoras, used the letters A, B, and C to represent the sides of a triangle, with C always being the hypotenuse. Pythagoras successfully proved that A squared plus B squared is equal to C squared. Meaning you can take the length of side A, square it, add it to the length of side B, which has been squared, and it will always equal the square of the other side. Now, there are lots of different proofs for this and a lot of different ways that it shows up. If you are curious about what those proofs look like, feel free to come in on a Friday, and I'm more than happy to show you. In the meantime, I'm not going to spend a ton of class time proving this to you, especially because I think this is review, and so I don't think you really need a ton of proof to know that it's true. The classic example of this is a triangle with a side length of 3 units, another side length of 4 units, and then a hypotenuse of indeterminate length. If you do this, you get 3 squared plus 4 squared is equal to, well, we'd have to figure that out. 3 squared is 9 plus 4 squared is 16, and we get 25. 25 is the same thing as 5 squared. So therefore, the length of this side is 5 units. Of course, not every right triangle works out so lovely. Some of them are a little bit more difficult to solve. Now, if we're looking at one that's a little bit more difficult to solve, we can kind of pick any numbers we want. Well, what if we said this side was 12 plus 17, and we wanted to figure out the length of the hypotenuse? We could simply go 12 squared plus 17 squared is equal to some number. In this case, we get 144 plus 289 is equal to C squared. 144 plus 289 is 13,433. Now, c squared is equal to 433. C by itself is going to be the square root of each side. We get the square root of 433. Now, are we done? The correct answer is no. We've got more to figure out. We have to see if the square root of 433, see if we can simplify that down. Now, 433 isn't an even number, so that's not immediately divisible by 2. 4 plus 3 plus 3 is 10, so it's not obviously divisible by 3, and it's not obviously divisible by 5. So we have to do a little bit more work to see if it's actually divisible by a number. I just double checked. 433 is prime, so there is no smaller version of this number. However, generally, we can go ahead and make sure that we can see if it's smaller.